Welcome back. So here is the second part of our fastText classification classifier or model. So now we do the text classification model, and we need first to download this zip file. So copy and paste it on Ubuntu. Okay, I shouldn't be having this 302, or I should. Oh yeah, I should. Okay, yeah. So I've saved it already. You should have like a downloading sequence here. Shouldn't take too much time. Okay, then we need to unzip it. Okay, run that command here again. I don't need to do it because I've done it. Alright, after unzipping, you should get this folder, fastText /0.1.0. Okay, and then you'll have to make it. If this if these two commands do not work, you can always create your own fastText folder. So for example, by running mkdir, like what they did on the second tutorial. This is, I mean, in worst case scenario, but this should work. Yeah, and to check like the functions we have on fastText, we can always run this command. Okay, but first we need to get access to the folder. Now we are in the folder. Now we run this. Yeah, those are the functions you can use. Supervised, skipgram, SIBO, which stands for continuous bag of words. Let's get our data with the labels. Okay, copy this. We have our files. Now let's get access to those files. I mean, at least to one of them, this txt file. So now we have the labels and the piece of text, or the question. Okay, so now we need to split up our data into a training set and a validation set. And in order to do this, we'll have to run these two lines. Okay, but before doing that, we might actually have to create these two files. So cooking.train and cooking.valid. Because if you go to the folder, like our original folder, which is fastText /0.1.0, you will not find these two files. So basically we need to create them first, and in order to do that, we'll have to go to our Ubuntu and use Vim, and then write like the name of the file you wanna create. So say for example I wanna create google.txt, and then what I should do is, so here you can specify what do you want in your data. If you want it blank, just type in 2 dots and then WQ. But if you want something in it, so first you type I and then hello. Oh yeah, and then escape. Yeah, so if you want to go to that hidden place, you'll have to go to this address on your Windows machine. So I'll copy this. Okay. So here is the address. Okay. Here is our folder. Yep. Cooking.stackItChange. That's what we got from the HTTP address, if I'm not mistaken. Alright. And these are the files we've created. See? Train file, valid file. So don't forget that dot train and that dot valid. Okay, they're extremely important. Yeah. So we've successfully installed these, created these 2 files. That's a good thing. Alright. By the way, I'll also leave links in the description about how to get access to this place, this hidden place, and another one about how to use Vim, VIM in Ubuntu to create files. Yeah, I think that will be useful. Alright. After splitting our data into a training and a valid set, so the total size is like this number, and we've divided into 3,000 and 12,404 respectively to our valid and validation and training data. Okay, so now we're gonna train our first classifier. Yep, and to do that we need to run this command. Okay, so I'm not sure if you also have to create this file, model_cooking. So I'm not sure if it comes with a package or not, but if it's not the case, it's not a problem. I've shown you guys how to do that, how to create a file. You will need 2 other files, which are the following. So models_cooking.bin, model_cooking.vec, the vector file. Yeah, so make sure to create these 2 files if it didn't come with a package. Okay, so for the rest of the tutorial, we're gonna use Jupyter Notebook to run this pieces of commands. So instead of using Ubuntu, so we're trying to make a prediction, and we will also try to find precision and recall of our model, and we'll try to make our model better by you can pre-process the data differently, or you can have a larger learning rate, or maybe use word n-grams. Yep. Here is our Jupyter notebook tutorial on fastText. So make sure to launch Jupyter on Ubuntu in order to find these files, the ones that you've created from the beginning on our Ubuntu execution or command line. Okay, so first thing is to import fastText, or you can also import it as FT or whatever you want to name it. Okay, our file will be cooking.train. Classifier will be made this way, .fasttext.supervised. Okay, you give it the file, which is cooking.train, model underscore cooking, which is the model we've built from the beginning. Okay, I'll label prefix and the number of threads running. Okay. Okay, now is the time to predict a certain input, a certain sentence. So say for example I want to predict what's the label of this sentence. So the label would be baking. Alright. Let's go to the next cell. Predict why not put knives in the dishwasher. Right, I'm not sure why does it print all of these outputs, but I guess if we add k equal 1, oh no, oh yeah, I remember. So you see here it's a list. If you give it a list as an input, it will give you only one output. But if you give it a sentence as input as a string, it will give you all of these outputs. So a lot of predictions. Baking. Here we have eggs, sugar, pasta. I'm not sure why, but yeah, we're just experimenting here. And another cell would be this. Okay, we're gonna test our classifier by using the cooking.valid, our validation set. Okay, and we try to print the precision, recall number of examples. You guys remember number of examples for cooking valid should be around 3000. We've defined that from the beginning. Okay. Okay. Oh yeah, by the way, if you use k equal 5, it shows the top 5 prediction that it can make. So baking, food safety, substitutions, bread, equipment, again in a list format. So something like this. Okay, so now we want to improve our model. And to do that, we're gonna modify epoch and the learning rate. So first, let's try with the epoch, and we'll get, yeah, see here, like we get more precision and more recall. And if we modify the learning rate, we get even better. 0.52, 0.227. Okay. we change both of them at the same time, we'll get slightly better precision and recall from the previous.